All right. What is the angular momentum of a 3.45 kilogram, 33 centimeter radius bike wheel traveling at 12.5 meters per second? Assume it is a thin ring. Okay. Yeah. Okay. Most of the mass is at the edge, right? Okay. Now let's do that. So remember, for a thin ring, I is equal to mr squared, right? So let's figure that out. I is equal to 3.45. It's probably a really heavy tire. I'm just going to say kilograms times 33 centimeter radius, so 0.33 meters squared. So 3.45 times 0.33 squared is 0.375705 kilogram meters squared. Okay, so now we know the moment of inertia. Oh, wow. Okay, let's see. It's traveling 12.5 meters per second. So we have to figure out the omega. Omega is going to be V over R. And I'm using, by the way, V as omega R, the tangential relationship. That's actually in the data packet. Okay, so let's see. 12.5 meters per second over 0.33 meters. So let's figure that out. 12.5 divided by 0.33 is equal to 37.87. And then 87 just repeats, right? Okay, and that is radians per second. Okay, so now we're ready. Are you ready for this great moment? This is as hard a problem as it could be. So it's I omega, right? So it's 0.375705 kilogram meters squared times 37 point, and quite a lot of 8 sevens, I'm just going to say, radians per second. All right, we can do this. All right, I've got it. Okay, so let's see. That divided by, oh wait, no, times. My gosh, times the 0.37. And I get 14.23. 14.23, and that's kilogram meters squared per second. Okay. Notice that the linear momentum is P is mv, right? So if we go I omega, we're really going mr squared times v over r, right? Okay. And so the angular velocity of this thing is, one of the r's cancels, right? So it ends up being mrv. MRV, yeah. That's what it ends up being, right? Mr. V is our angular momentum. Okay. Well, that becomes important when we look at angular momentum of electrons going around atoms. But anyway, which we'll look at next year.